to Talk a Little, Learn a Lot, the American Society of Naval Engineers podcast. I am your host, Stephen Phillips. In this podcast, we talk a little and learn a lot about naval engineering while inspiring the next generation of STEM professionals. Today, I'm joined by Captain George Galdorisi, U.S. Navy retired, to discuss his recent Naval Engineers Journal article entitled Naval Engineers Must Embrace Artificial Intelligence Technologies to Make Tomorrow's Fleet More Autonomous. Captain Galdorisi, George, thank you for joining me on the podcast. I look forward to this discussion.
Thank you, Stephen. I appreciate being on your show.
George, would you please start by introducing yourself to the Talk a Little, Learn a Lot audience?
Yeah, sure. Brief bio. Grew up in New York City. Thought I was going to be in an engineering kind of profession. And I was looking for adventure. So I went to the Naval Academy, a naval aviator for 30 years, and then still wanted to scratch that technical itch. So I worked at the Naval Information Warfare Center Pacific for 25 years. We're the Navy's command and control lab, and just retired last year. So here I am having more time for writing and doing things for Naval Engineers Journal.
Fantastic. Well, you point out that every major technological revolution has changed the way the Navy designs and builds ships, from steam to electricity to digital systems. Where do you think artificial intelligence fits in that historical progression?
Yeah, I think it's a major inflection point, and don't believe me. Several years ago, in a New York Times article, our former chairman of the Joint Chiefs of Staff, Mark Milley, a Princeton grad, said that artificial intelligence is the most significant fundamental change in the character of war ever recorded in history. So that says a lot. So let's drill that down to the surface fleet and what readers of the Naval Engineers Journal are most interested in. It's adapting our ships, our fleet, to mine the benefits of artificial intelligence. So I think that's at a very nascent point. To be honest with you, if you follow what was happening in the wars in Iraq and Afghanistan, air and ground systems were adapted using artificial intelligence. And once those wars ended, it was time for unmanned surface vehicles to take center stage. So we're catching up a little bit in the surface Navy, but I think we're a little ways away from harvesting those benefits because it's fairly new.
Artificial intelligence means different things to different people. For the ASNE audience, how should naval engineers think about AI, and what misconceptions would you like to clear up?
Yeah, well, before defining the first part of your question, I'll take the second. There is fear in the American public about artificial intelligence. We've been fed editorials from everything from the New York Times, Wall Street Journal, Economist about how it's dangerous to man. I mean, I think without editorializing too much, Elon Musk said AI will be the end of humanity, and parenthetically, that's why we all need to move to Mars. And then movies from 2001 Space Odyssey to Her to Ex Machina has injected real fear. So when you say AI, Americans get pretty scared. And when you say military AI, they get really scared. So that's one of the things that's impeded AI adoption, both in the civilian sector and certainly in the military. But to break this down, AI is really a catch-all phrase for three things that allow us to do what we do today with the technology. The first one is big data, and that attempts to curate huge amounts of digitally recorded data in order to make sense of it and derive value from it. So artificial intelligence is really going back scores of years to when this first emerged, is defined by its original developers as simply the ability of a computer system to be able to perform those tasks that normally require human intelligence. And then finally, machine learning is the third part of it, and it's the ability of computers to modify their decision making when exposed to more data. So you use AI to build something, and then when you give it more data, it adapts and does more useful things. So sorry for the sort of academic tutorial, but it's important to understand that AI includes those three elements.
Oh, indeed, George, and I'm here for all of it, so I appreciate it. In the article, you discussed moving from automation towards autonomy. I'm interested, where is that line, and when does an automated system become an autonomous one?
Well, an automated system, let's talk about a unmanned surface vehicle. An automated system would be if you put in 10 GPS coordinates, then that unmanned surface vessel would go to one, and then the next, and then the next, etc. Um, Artificial intelligence, if you insert that or put that on that platform, um, and tell it what the objective is, it'll figure that out. One example of this in the air world is Israel has an unmanned aerial system called Harpy, and they'll send Harpy out to an area of operations and tell Harpy, uh, don't don't hit the decoys, hit the tanks. And Harpy will look around and spend some time, and the artificial intelligence will enable Harpy to find the tank. And that's because Harpy was fed information, thousands of bits of information to accomplish that. So that's the essential difference.
Many engineers are already using advanced modeling, optimization, and simulation tools. What does AI add that previous generations of engineering software could not accomplish?
Yeah, well, what it's doing now is basically automation. And we haven't really mined the abilities of AI for several reasons. Number one, it's that fear about, what you will do. And I mean, there's a UN organization called the um, the Society to Stop Killer Robots, because there's that sort of fear germinated from things like Terminator. The other thing is in the civilian sector. And you know how everyone finally realizes that everything you type into Amazon, every keystroke you make is captured in some big database for reasons of commercial reasons of selling you what they want to sell you. So that's called digital exhaust. Um, and again, the big tech companies exploit that. And I'm not here to bash them. I'm saying it's business. Um, in the military realm, there is no digital exhaust. We have to go out and collect all the data we want from different databases that are built separately, and that's a chore and that's expensive. And so, let me go back. If Procter and Gamble's H department has AI algorithms that do great HR things for them, we can adopt that in the Navy pretty straightforwardly. But if it's an operational thing that we want AI to do, we have to first mine the databases and then curate them so there's useful information, and then we can develop AI apps that do things that we want them to do.
George, if a ship designer were starting with a clean sheet of paper today, how would AI change the architecture of a future warship?
That's a great question, and I've thought about it. I don't think it's going to change the physical layout of the ship much, if at all, because it's software. And when you think about it, uh, serving aboard Navy ships as we both have for many years, you know, the hardware stays the same. Uh, Back in the day, they would mail you another disk to put into the hardware, the next update of whatever the software was supposed to be doing. So I don't, I'm not a prognosticator, but I just don't envision the ship being that physically different at all.
What shipboard systems do you think are most likely to benefit from AI first? Combat systems, machinery control, maintenance, logistics, navigation, or is it something else?
I think it's going to be combat systems. And AI can do a lot of things, and most of what I've learned at Naval Pacific in my quarter century there is one of the most prominent things that uh, the Navy anticipates AI will do um, is help in decision making. And the DoD founded a joint artificial intelligence center, and an Air Force officer, Lieutenant General Jack Shanahan, led it. And he said he opined the most valuable contributor of AI to U.S. defense will be how it helps human beings make better, faster, and more precise decisions, especially during high consequence operations. And this is probably the subject of a full a, a full podcast of its own. But we've studied at Naval Pacific how bad decisions were made, and we dialed it all the way back to USS Stark, who took two Exocet missiles because they misinterpreted what aircraft were coming at them, to the very tragic USS Vincennes, Iranian Airbus shoot down. In fact, we had Captain Rogers at the lab, where not just scientists and engineers, but psychologists, talk with him and said, "How did this happen? What were you thinking? What was going on?" Et cetera, to the more recent and very tragic USS Fitzgerald and USS John S. McCain tragedies. The collisions with the commercial vessels was killed between them several dozen sailors. And we firmly believe that the data to make the right decision was on that ship, but it didn't get processed. It didn't get displayed in a way that decision makers could use it, and tragedy ensued. So, not to say the Navy always makes bad decisions. It doesn't, and makes thousands of good decisions every day, but you still don't want those outliers there having people die. And again, our contention is that, those things could have been averted by use of AI.
Your article isn't just about ships, it's about the fleet. How does AI enable a force in which manned ships and autonomous systems operate as an integrated team rather than as separate capabilities?
Well, I'm not being cute about this, but we'll find out. We'll find out this year, because USS Theodore Roosevelt Strike Group is deploying with two medium unmanned surface vessels. And I'm sure there are plans for how they're going to use them. I'm not privy to those, but that'll be the acid test. And that's something that, going back to former CNO Gilday, that's what he has promoted, deploying unmanned surface vessels with strike groups. His desire back when he made this statement was that they deploy by 2027, 2028. So kudos to the Navy for doing it sooner, just to learn how that man-machine teaming will work.
Engineers tend to be skeptical by nature. What are the biggest technical hurdles that still have to be overcome before AI can be trusted in mission-critical naval systems?
Yeah, well, going back to one of the earlier questions, it's finding a way to gather and to curate all the data we need to enable AI to work, by having plenty of data. So if you think about it from your naval service mind, every system is built by a contractor, and it's proprietary software, and that's fine as long as the system works. But we want to take the data from all of those systems and harmonize it so it can be useful and then curate it. So I think that's the biggest impediment is figuring out how to, you know, take that make that big data useful to let artificial intelligence mine it and do what it does.
Naval engineers have always valued deterministic systems that behave predictably. AI often produces probabilistic outposts. How should engineers reconcile those two worlds?
Well, it's an issue of trust. And without shamelessly promoting a book that Sam Tangredi and I wrote for the U.S. Naval Institute, the AI at War, it's an anthology. And we talked to people from Admiral Jim Stavridis to Admiral Mike Rogers to Paul Scary, who wrote Four Battlegrounds, to Admiral Scott Swift, and prominent people who were smart people about their predictions for what AI would do for the Navy. Bob Work as well was one of the authors, and it was all positive. I mean, it wasn't like pep rally positive. It was, yeah, we need to pay attention to this. We need to mine this. We don't need to wait for 10 years for things to be wrung out, and it's 100% solution. Let's go out with the 25% solution, and that's really what the Theodore Roosevelt Battle Group is doing. These medium USVs that they're using were not purpose built for this battle group. They've been running out for years and years in exercises, experiments, and demonstrations. So it's like, okay, look, these can go. These are good candidates. Let's see what we do, and then let's see how we can improve them.
AI systems are only as good as the data they're trained on. How should naval engineers think differently about collecting, curating, and governing engineering and operational data?
Well, I don't, I don't know what every program office in a Naval Sea Systems Command is doing, but I don't know that there's a PMS, a program office who's assigned to do that. I think it's probably a part of many program offices. So without making it a bureaucratic kind of thing, I would hope that there are people organizing to learn how to do that, or to see if they can do that, to bring all that disparate data together. Um, so yeah, that's step one.
George, verification and validation have always been cornerstones of naval engineering. How do you certify an AI enabled system that can continue learning after it has been fielded?
Well, even though I mentioned that there are three parts to AI: big data, artificial intelligence, and machine learning. Um, I would be when you insert a system on a ship. I'm not sure we want it to machine learn. I mean, in the civilian sector, they have things, when you're using things like Chat GPT or Claude or something, they say it hallucinates. So I think I'd like a system that does the first two, big data and artificial intelligence, and not give it more data or expose it to more data and hope that it does better. That to me is too much of a reach, actually, if that makes sense.
Yeah, indeed. Another other themes that I took away from your article is that AI should augment engineers rather than replace them. I think this was a key point of the whole thing. Which engineering tasks do you hope AI will take over, and which ones should always remain the responsibility of human engineers?
Yeah, well, I'm not sure just human engineers, but all naval personnel. Going back to what Sam and I uh, talk about in our books is you want you still want a human either in the loop, meaning monitoring everything that's going on every second, or a human on the loop, which again, for some of your younger engineers, this will make a whole lot of sense. But back to the composite warfare commander, um, ConOps, where you had the ASW commander and you had air warfare commander and all the commanders in a battle group making decisions, but the admiral, the composite warfare commander, had command by negation, where he could, again, he was on the loop, not in the loop, but command by negation, where he could jump in and say, no, don't do that, or do this other thing. So I think that's what's going to happen as we use AI technologies in the fleet is a human in the loop or on the loop. And again, it's not Paul Scari, who's a brilliant scholar who wrote wrote a very wonderful book on AI called Four Battlegrounds. Said human or AI is a false choice. What you want to do is have the AI augment what the human does and work together serendipitously. So that's really the promise of AI. It's not a magic thing you put on the ship and hope it does good. Just to segue a little bit, a former commandant of the Marine Corps ran an experiment. He had two platoons, and he gave one platoon a black box, and he says, "This was a wonderful thing, and take it out to the battlefield, and it'll do this and that and the other thing." And he gave another group a black box, and he said, "You have to train this. You have to talk with it and tell it what you want it to do and how it does it, et cetera, et cetera." And then they did this, and guess which group actually used the black box? The one that had programmed it to do what it wanted to do.
Yeah, of course. All of this is related to my next question. Trust is essential aboard a warship. Before a commanding officer relies on an AI-enabled system during combat, what has to happen during the engineering and testing process to earn that trust?
I only know this because I was chief of staff for Carrier Strike Group for 5 years, 5 different admirals. There's a long pipeline, first of all, for the people in that strike group, as far as schools and whatnot. And then the ships of the strike go through a fairly extensive workup. So that the idea is, which has happened in the past, unfortunately, you don't want someone running down the pier as they're taking the lines in saying, "Wait, take this black box. It's fabulous. It'll do all these things for you." You want to have it injected at the very beginning of the workup cycle to build trust, just the way the admiral described. And again, I'm not trying to promote my friends or associates' books, but there's a wonderful book by two gents, Peter Singer and August Cole, called Burn-In. And you know what burn-in means with software. You test it and you make sure it works. And the high concept for the book is there's an FBI agent who's given an AI and a robot, and she has to train it before they go out in the field. And, it describes how she does this and the process and whatnot. But that's what it's all about. It's burning it in to make it, part of the combat system. So I don't know if I call that out specifically, but I think the biggest thing that the AI can do is in the combat systems and the decision making.
Indeed. I really enjoyed that book. And I was working on robotic systems at the time. And Peter Singer, while he was in his research phase, came by and spoke with me and some of my colleagues. So that was fun. We're not mentioned in the book or anything, but I really enjoyed it. That was a fun book. Most of the fleet we'll have in the next decade is already in commission. How difficult will it be to retrofit meaningful AI capability into legacy platforms?
Yeah, Steve, that's a great question. And it's something I've thought about, but the whole idea of harmonizing legacy systems with new system is, I'll just put it this way, it's above my pay grade. I just don't, I don't have any astounding thoughts about that. Someone obviously has figured it out, because we've introduced, new systems into the fleet since there's been a fleet. So I think that's just a challenge that we should anticipate and, give time for those things to, just like in Singer and Cole's book, those things to get burned in.
What changes should NAVSEA program offices and industry be making today so that AI becomes part of the acquisition process rather than an afterthought?
Yeah, well, this may sound trite because it's harder than it sounds, but um, just treat AI as something that's integral to the ship and not something you bolt on to the last minute at the last minute. And let me just give an example. So my career was in with the H-60 helicopter. We used to call it Lambs Mark III back then. And for all your listeners, the theory, and this evolved back in the 70s. The theory was you take a P-3 aircraft, which has about 10 people aboard, and you chop off the front end and put it up in the air, and that's the helicopter. And the back end you have on the ship, and you have it on the ship because the ship's more stable, it has more room, et cetera, et cetera. So there were 5 individuals on the ship, each with their own workstation. There was the Lampsey Taco. He was the one who took care of all the tracks. There was the ASMO, was the AFW person, the REMRO radar person, ESMO, the EW person, and then the TAO. And in the helicopter, they all had their own station. In the helicopter, you had one small screen between the pilots, about as big as an iPad. And this isn't aviator bravado or anything, but guess who had the best picture? The 2 pilots in the helicopter. And the reason why was all these people on the ship with their own station, doing their own thing, never had a rugby scrum where they got together and said, well, what did you see and what did you see? In the aircraft, the pilots were forced to have all that information together because they only had one screen. So they had the ASW tracks, they had the radar tracks, and they said, oh, this correlates with this, and they had a better picture. So again, the design of the system, Lambs Mark III, the ship system, was flawed because they assumed that the people on the ship would have the better picture. So again, that should go into the design of these AI-enabled systems to, anticipate what was anticipated in Lambs Mark III. Sorry, that's a really long answer, but I thought the analogy would help.
Indeed, indeed. AI has tremendous potential for predictive maintenance and logistics. Where do you think we'll see the first measurable improvements in fleet readiness?
We're using those kind of systems already, particularly in the engineering world. It's like, how many hours will it be before this this system breaks down? And those are doing pretty well. So I don't really envision too many improvements. So that's kind of my pay grade. But I did want to offer an analogy. So I can't think of any parent when that new baby is born who says, I hope you can work to the baby. I hope you can work at a recycling plant someday. I mean, it's kind of icky work. So using AI, recycling plants have totally changed the ConOps. Now what they do is there's several alarms that pick things out of the conveyor belt. One is supposed to look for glass. One's supposed to look for plastic. So what they do is they'll show these arms tens of thousands of things made of glass, tens of thousands of things made of metal cans, and train them to pick those things up. And it's been fabulously successful. I mean, it's taken the human pretty much out of the loop, and humans don't have to do this icky work anymore. So I think using those examples from industry, I think naval engineers will say, hey, we could use this on our ships.
George, throughout naval history, breakthrough technologies have succeeded only when leaders are willing to change organizations, training, and culture. Is the biggest challenge today technical or organizational?
That's a rough question. I think most people would default to both. But I mean, I think if you look at the ownership that Admiral Wayne Meyer had in the Aegis world, um, that to me is organizational. I mean, the technology existed, but to put that all together um, in the ship, starting with USS Vincennes, um, that was operational and organizational. That you had one person who was willing uh, to do that, and you could go back to an earlier example of Naval Rickover and the nuclear submarine program. And I just wanted to just maybe pause on that a second. The first nuclear submarine, USS Nautilus, was launched in 1954, and that was what, 9 years after the bombing of Hiroshima and Nagasaki, and there was, I mean, you could go back and read about it in that era. There was tremendous um, vocal opposition to that. We're going to boil the ocean. We're going to do, these things are to explode and threaten humanity. So I think the other part of that is just like Admiral Meyer did with Aegis, it's advocacy and quelling fears that this, again, the shrill opposition to AI in the civilian world is to, provide consistent advocacy for wanting to have these in Navy ships.
George, whenever somebody mentions Admiral Meyer on the podcast, I have to have a little celebration because indeed the name of the podcast, Talk a Little, Learn a Lot, is an homage to Admiral Meyer's mantra, build a little, test a little, learn a lot. So always love it when he's spoken of here. If a young engineer listening to this podcast wanted to prepare for the next 20 years of naval engineering, what skills would you recommend they begin developing now?
Well, I think young naval engineers or engineers right now, they have, and again, it was the same thing at, just if you don't mind, an example from Naval Pacific. There was a command and control department. There was a communications department. There was an ISR department. And they were all stovepipe, not a criticism, but just, people wanted to do those things. So I think a naval engineer who wants to work, whether it's in combat systems or engineering, needs to realize that they'll have to have some knowledge of AI to do what their primary discipline is. So I guess another way of saying it is like college, you have a major and you may have a minor that you're doing, if that makes sense.
Indeed. George, let me end where your article begins. Invite you back to Talk a Little, Learn a Lot in 2035. What would you hope to see that would convince you that the Navy has truly embraced artificial intelligence and created a more autonomous fleet?
Well, I think just that people not be ignorant, and that's a strong word, of artificial intelligence. You say, "Oh, that's her job," or that's his job. But to realize that this is now mainstreaming into the Navy, and it's happening in some of the academic institutions. The Naval Postgraduate School has seminars on artificial intelligence for people from lieutenants to captains. Naval War College has seminars on this. Naval Academy has courses. So I think we're slowly making people aware of what AI can do. And again, it's calming some of those fears that people see in editorials and movies and stuff like that. So I think that's the biggest thing.
And so thank you, Captain George Galdorisi, for taking this time to discuss your recent Naval Engineers Journal article entitled Naval Engineers Must Embrace Artificial Intelligence Technologies to Make Tomorrow's Fleet More Autonomous. As I said before you and I recorded this show, I've been a fan of your writing for some time, so I hope to read more, and I hope to have you again on Talk a Little, Learn a Lot, the podcast of the American Society of Naval Engineers.
Thank you, Stephen, and hope to be on your podcast again.